Now, the other part which I need to look at is that I define my K2 as the value of the function x of I plus P1 times H, y of I plus Q11 times K1 times H. And what I'm going to do is I'm going to expand this as a Taylor series. Now, this is a Taylor series in terms of two variables. So if I have a Taylor series where I want to calculate the value of the function at some point which is a ahead of x and b ahead of y, the first three terms of the Taylor series are given as this: fx comma y plus a times del f by del x being calculated x comma y plus b del f by del y being calculated x comma y plus the order of a squared comma b squared terms will be left over. So that's what's going to happen when I'm going to expand this. So when I expand this, my x will be x of I, my y will be y of I, my a will be P1 of H, and my b, which I have here, will be Q11 times K1 times H. And I'm only taking the first three terms of the Taylor series of two variables now. So the leftover terms are the order of a squared and b squared. So if I do that, and let me write this down. If I do that, this is what I'm going to get. I'm going to get for K2, I'm going to get the value of the function at x of I, comma y of I. That's what I'm going to get. So I'm using my Taylor series expansion. Plus, I'm going for A is P1H, so it's P1 times H times del F by del X at x of I, comma y of I. Plus B, which is Q11 times K1 times H, which is del F by del Y being calculated x of I, comma y of I, plus the order of H squared terms. Because I have A squared, B squared terms there, so since everything has H in it, so it'll be just order of H squared terms. Now, if I go back to my the formula which I wrote for Runge-Kutta second order method, which is this: A1 times K1 plus A2 times K2 times H. I'm going to substitute this expression for K2 in here, and then I'm going to equate it to what I had before. And that's how I'll be able to get all the expressions together. So if I expand this, this is what I'm going to get. I'm going to get y of I plus A1 times the value of the function x of I, comma y of I, plus A2 times K2, and K2 is this times H here, because I have A1 times K1 is nothing but the value of the function at that point, times H. A2 plus K2, I'm going to substitute all of this here. So I'm going to get A2 times the value of the function at x of I, comma y of I, times H. H is coming from there, plus A2 P1H del F by del X at x of I, comma y of I, times H, plus A2 Q11 times K1 times H, del F by del Y at x of I, comma y of I, times H, plus order of H cubed terms. The reason why the order of H cubed terms is because it's of the order of H square right here. This is of the order of H square right here. So since I'm multiplying by H, I'll have the order of H cubed terms right there. So what I'm going to do is I'm going to take this expression which I have for y of I plus 1, this expression which I have for y of I plus 1, and I'm going to equate it to the terms which I have for which I got previously, which are right here. So let me just take this here. So this is something which I got previously, and this is one expression which I got, and then this is something which I got by using the expansion of the Taylor series of two variables right there. So once I equate the two, this is what I'm going to get. I'm going to get A1 plus A2 equal to 1, A2 P1 is equal to 1/2, and A2 Q11 is equal to 1/2. It is not very easy to show it on the board how I get those by equating the terms, because there are so many of those terms. So I would like you to do that as homework to see that how did I get this expression, this expression. It's only to basically to equate the terms which are the same from the two expressions, and you'll easily find out that you get this has to be equal to 1, this has to be equal to 1/2, and this has to be equal to 1/2. And that's how the Runge-Kutta second order method equations are derived. And that's the end of this segment.